Welcome back to the Advent of Cintran 2025. We are coming up on day 10. If you're watching on YouTube, you can skip ahead by about 2 minutes because the puzzle unlocks just over 2 minutes from now. So let me check my stream, make sure I'm live. Looks like I'm live. Is my audio working? All right, everything is working. So, I don't know how much time we have, but I did eventually figure out day 9, and I didn't have to resort to cheating, like looking up other people's solutions or anything like that. It did take quite a while. One of these days, it might be today, it might be tomorrow, it might be day 12, we're probably going to get something that I can't solve without cheating. Typically every year there's at least like 1 or 2 part 2s that I can't figure out. And another unknown is, are there going to be 2 parts for day 12? So in previous advents of code, day 25 doesn't really have 2 parts. There's just part 1. And then there's a token part 2, but part 2 is just if you got the other 49 stars, you get this last star for free. So there's really not a part 2 on the last day. I don't know if we're doing that this year with the reduced number of days, so I guess we'll find out. Sometimes, like the last day is a little bit easier because of that. Other days, I think it was 2023 with the GraphViz problem. Well, I didn't use GraphViz, and that was like one of the hardest problems for me. So, yeah, I don't really have enough time to talk about how I did day 9 right now. There's only 25 seconds until this puzzle unlocks, so I don't know if I'll talk about that. It's in the video description of my YouTube video for day 9. I only streamed part 1, and then I tried part 2 and failed, and I finished it off stream. So, yeah, day 10 is about to unlock here. Let's go. Let's download my input. Wow. That looks complicated. So I guess that's the test input. Okay, and this echoes the test input. Finally, on a 2-digit day. Joltage again. Which day was that? Day 3. So we have an indicator light diagram, button wiring schematics, and joltage requirements. What are the buttons? Okay, so these, each one of these is a button. What's in the curly joltage? What are the joltage requirements? So if you push these buttons, if you push this button, starting with this state, you get to this state. Okay, I think I get that. Oh, we can ignore the joltage requirements. And these inputs are huge. Well, 1, 2, 3, 4, 5, 6, 7 lights, and 1, 2, 3, 4, 5, 6 buttons for just the first input. We have like 100 of these. So wait, do the lights start off? Yeah, they're initially off and we have to get to this state. The goal is to get there. Okay. On all of the machines. Well, of course. That's our checksum. Do we just brute force this? How big are the numbers? We have like mostly single digit numbers, except for the joltages, but those don't do anything for part 1 apparently. What is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the joltages seem to have the same size as the lights. Potentially that's a clue for part 2. Six. So there aren't a lot of zeros. I mean, you can sort of think of this like a vector space, and you're adding up these vectors to try to get to some result modulo 2, because they're on or off, so it's like a mod 2 system. And if we had a lot of zeros, then we would basically have an obvious basis. But we don't have a lot of zeros. So it's hard to get into this coordinate system. I can do brute force, but we have like three, four, five, six. So like I don't know what the max number of button presses I'm gonna have to do is. For I mean, that's not a lot. If I only searched pressing each button 4 times, or up to 4 times, that's like a manageable number of things to search. But I don't know if that's going to find solutions. Like, you don't know how high you have to go. I'm kind of tired. I might not even get part 1 tonight. Oh, no, why am I looking for zeros? So we never have anything that's all dots. That would be the trivial solution, just don't press any buttons. Okay, so we're trying to solve this. First we try, can we get to this state with 1 button press? So we try pressing this button, that doesn't work, we reset everything. We try pressing just this button. We cycle through all the buttons, pressing each of them once, and none of them work, because what do you have to do, 3 for the first one? First machine, 3, oh, the fewest is 2. Yeah, so you try single button presses, but that doesn't work. And then you try 2 button presses. So you try this button twice, then you try this button and that button, then you try the first button and the third button. So you go through like every possible combination of buttons, including the same button twice. So I think combination is not the right word, but you could think of that as a base 3 number, where each digit represents how many times you press each button. And you have 1, 2, 3, 4, 5, 6 digits. And the digits have to sum to 2, because you're doing 2 button presses. Not really sure what data structure I'll use for that, but that's the brute force strategy. Is that going to scale to the real input? I have no idea. But it should be workable for the test input if I can write the code. And we're 13 minutes in and I haven't even started writing code. I just have to parse this stuff. Like even parsing this is going to be a bit of a pain. Well, we're going to split by spaces. And then this will be the first word. Yeah, and we'll ignore the last word, where words are delimited by spaces. Not that. Okay. Those are my words. So I want to convert this into a Boolean vector, because then I can easily apply these to a Boolean by just doing not equals, or like Boolean equals not Boolean to toggle the state. You could have a number and make it base 2. Would that help us optimize? Or a number and then take it modulo 2. I don't know if that would help. I think I'm going to do Booleans. And these are the lights. So the lights string is the first word. And then we're going to trim that. So ignore the first character. There's not really any sense trimming, because we're just going to have to iterate and convert it to a Boolean anyway. What do they call this? Goal. -2 because we're ignoring the brackets, or yeah, the square brackets. Now, so let's goal is a Boolean vector. Is there an easy way to do this? Char. Can I split a string into a vector of characters? If concatenating a vector of strings into one string. Oh, yeah, here we go. Vec str. That's exactly what I need. vec str lits string 1 through n lits -1 equals hash. So that should be false, true, true, false. Just have my parenthesis in the wrong place. That didn't work. Why is the size off? Oh. Because I already subtracted 2. Okay, false, true, true, false. False, 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 true, false. False, true, 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 false, true. Those seem reasonable. I don't know if I want to do this. It's so late. I'm tired of staying up past midnight. Then what? Now I need the buttons. So these are all different sizes. That's kind of a pain. What if I also make these into Boolean vectors, all of size 4? Then I can put them in a matrix. That's an easy way to store them. And then I can toggle these by XORing it. XORing? Some kind of logical operation is going to let me toggle. I think it's XOR. XOR is like the Boolean addition, right? So false, false. Yeah, I think if I XOR with a button Boolean vector, then it's just that should do the toggling. Okay. So we're going to have buttons, and the number of buttons is the size of words -2, because now we're ignoring the lights, and we're ignoring the joltages thing that we're ignoring for part 2 at the end. Or we're ignoring it for part 1. What are there, like 6 buttons here? 6 buttons for the first one. 6. 1, 2, 3, 4, 5, 6. Now, we're going to set up this Boolean matrix for what the buttons do. We're just going to allocate it with falses, and it's going to be number of lights by the number of buttons. I guess let's look at the last one. So, because I don't want to scroll up every time. So we have the first button, then the second button, and all the way up to the last button. That seems reasonable. Now I just have to parse these numbers and put them in the Boolean matrix. I might just do that all in one line because I'm feeling fancy. So butts, the whole row, or every column, row IB, equals not every column. So some slice here. And it's going to be parse I32 delim, the button string, and now parentheses and commas are going to be the delimiters. This will effectively just ignore the parentheses for us. So that should set my buttons. And we should have a matrix, where in the first row of the matrix, 0, 1, 2, 3, and 4 are true. Then the second row, 0, 3, and 4, the entries in that row are going to be true, and so on. So let's print that. So these ones should be true. 0, 1, 2, 3, 4, not 5. 0, 3, and 4. 0, 3, 4. This one has 5 true, and this only has 1 and 2 true. Okay, we have parsed the input. Now all we have to do is solve the problem. I spent like 13 minutes thinking about this, and I can't think of anything but brute force. So we're going to try every possible 1-button press, and then every possible 2-button press. And we're going to break out of this loop as soon as we find something that works. I know from the input none of them will work with 0 presses because we never have a light state or a light goal state where it's all dots, so we can just increment 1 immediately. Now, how do we iterate through these? Could I use recursion? So it's kind of like a base n press big number where we have n butts digits. But we want the digits to sum to n press. So that's a weird limitation. I just don't know how to set up my for loops to do that. If I wasn't so sleep deprived, I might have a clearer idea of how to do this. Could just Google this, but I feel like that's cheating. It's like N choose K, but you're also allowed to repeat selections. My cat sounds angry or distressed. She's okay. It's okay, Callie. I'm not doing part 2 today. I'm not even going to read part 2 tonight because I want to get to bed. And if I read it, I'm going to think about it, and then I'm not going to be able to sleep. So what if I just write them out manually? I think that might help me think about this. So, what do we have? 1, 2, 3, 4 buttons. So we're going to press the first button once. And then it's just going to be like a diagonal matrix. Those are all the ways to press some combination of 4 buttons once. Total of 1 presses. And that's the n press variable. Now, what if we go up to 2? So we press the first button twice. That doesn't work. What do we do next? Maybe I want a smaller example. How about 3 buttons? Because there would be like 16 of those. There will be 9 of these. Are there 9? So we can press the first one twice, or we can press the first 2 once each, or we can do this. It's like it's like if this is 2, we can't make it any higher than 2. So we have to make something else 1, but to make something else 1, we have to decrease this one. So that's why we went here. And then we've tried everything with the first one at 1, haven't we? So this is 2 total presses. So then we have to set this to 0. And then we can do 1, 1. Or we could do... Is that all of them? So let's look at the symmetry. We have 2, 1, 1, 0, 0, 0. We have 1, 2. We have 2 1s, and we have 3 zeros. So the counts of each digit in this column are symmetric in some sense. Then we have a 2, 2 1s, and 3 zeros. I think those are all. So there are 6 of them. That's less than I expected. I guess let's work it out with 3. Three total presses. And like, how do I write a loop to generate these for me? So 3. These should just explode at some point. 2, 1, 0. 2, 0, 1. 1, 2, 0. 1, 1, 1. 1, 0, 2. And then 0, 3. Is that all? One, 3, 2 twos, 3 ones, and 4 zeros. 1, 3, 2 twos, 3 ones, 4 zeros. I guess that's it. So how do I write a loop to do this? So basically we start with the maximum number in the first button. Then we decrease that and we slide it over. I don't know how to do this. Combinations with repetition. That's not really what I want. I don't want to calculate the number of them. I want to generate every one of them. I apologize for using AI. This is cheating, but we're getting into desperate straits here. Have I done this in a previous year? I maybe. So can we think about this a different way? So this is trivial to generate. My computer fan, my laptop fan is going crazy. I I think it's that fucking Geeks for Geeks website. So many ads. Yet my CPU usage just dropped. Like I'm hearing wind whooshing. It's crazy just from a laptop. So I can generate these trivially. Now, to do all the possible 2-button presses, you just take these and combine it with that could use a lot of memory if I just save all of them. You take like any two of these. So you take this one and add it to itself. You take this one and add it to that one. You take this one and add it to that one. And doing that, you can get all of these combinations. Now to get these ones, you take every possible one of these and add every possible one of these. I don't know if I'm describing that very well, but can I do that without saving like a whole matrix of these in memory? I don't really want to do that. Can I do it recursively? Is that going to be something that's efficient? Like I could do it with nested for loops for a fixed number of buttons, but my number of buttons is variable, and that's what's making this difficult for me to think about. What the hell is this thing? Rosetta code, that's reliable. So long. Okay, see, this is manageable. Uh, so N is N press. K. No, N. I think N is N buttons. K is N press. Let's just match the C style. Why not? For I in. I hate these negative loops. K 0 negative 1, because this is not inclusive of 0. So that should be okay, right? Pause. What the hell is pause? Why did they change up the bracketing style suddenly? Brace style. Pause is initially all zeros, right? Four. Yeah, but that's... Do I have these backwards? Well, if it's like that, I have to allocate it inside of here, because the size is changing. Is there just one extra? All right, what the hell does this do? I think it's gonna crash. For loop step is 0. Step -1 to 0. I think that's what I wanted. Oh, that's, well, it keeps going. Because I haven't like checked if I reached my goal. But am I getting these right? So I want to break when like n presses 3. Now what the fuck does this mean? So I think it's like off by 1. It has to be off by 1. Because they have n equals 3 here, but their pause has 4. So I think there's just a buffer because of this weird break condition. Okay, so we press button 0, button 1, button 2, and button 3. We press 0 twice, we press 0 and 1, 0 and 2, 0 and 3. That, I think that makes sense. Yeah. That looks good. Okay. Whoa, 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 whoa. Can I just link to this section? Yeah, there we go. That's in the URL. Okay, so we have those. Now, I have to apply my button presses. I don't know why they did it like that. Maybe there's no better way. It's kind of weird. All right, so I don't know if that makes sense anymore, but because it doesn't really match the pause array. I think pause, well, it's the positions of the things that you're pressing. So state is going to be all false initially with n lights. And what are we going to do? We're going to iterate through the pauses. And we're going to XOR that button with the state. So state XOR equals, is that my XOR operator? I think so. But Now what are we doing here? State is size nlets. Butts is nlets by nbutts. So we're going to put a colon here and then p there. I think that's it. And if all state equals let's goal, break. We might get part 1 here. I can't do it with state. Really? I can't do this? What's the point of having an array-oriented language if I can't do array bitwise operations? For I in 0 nlets, we will just put I there and replace the colon with I. That's what that was shorthand for. Hopefully this works. Don't I have XOR? What the fuck is XOR? I think I used the same thing. It's not that? Are you fucking... Oh, that's a bitwise operator. But this is not bitwise, it's Boolean. I guess you could have like a bit vector, and then you would be able to do this. Can't do that, can you? I think this is just one of the unfortunate operators where you have to write things like that. Like there's no plus equal version of this operator. Okay, so we found a solution with 2 button presses, right? Button 1. No, that's 3 button presses. It's button 0, 1, and 2. Oh, but this is for the last one. So remember, we're ignoring the first thing here because of the way that C code was implemented. So we have 3 button presses, 0, 1, and 2. Is that correct? 2. Let's stop on the first one, because I think that has fewer buttons. So button 1 and button 2. The last 2 buttons. Well, they say one way that you can do this. They don't say it's the only way. Two plus 3 plus 2. Oh. Because I'm not breaking out of the outer loop. just had it hard-coded to break at 3. Okay, so that's 2 button presses. Uh... So then sum plus equals n press. 7 for the test input. Now, does this scale? I'm just brute forcing this. I hope, because I have no idea how to optimize this. I think it's finding solutions. If this is right, I'm not even going to look at part 2 because it's already 1 a.m. Fuck. What the fuck, man? Why does it never tell me if I'm too high or too low anymore? Do I have like a virus that's hitting a rate limit on Advent of Code? It tells other people, right? Somebody logging in as me? I got 7. Did I paste in the correct thing? I have to rewind my stream. How do I rewind here? How the fuck do I rewind? Can I do this on mobile? Maybe not. Fuck it. Because there was the one day where like I pasted the time that it took my thing to run instead of the answer. Okay. Well, now it tells me it's too high. Didn't tell me anything last time. What? What is up with that inconsistency? So, we find a solution with 2 presses. And this one should take 3. So that takes 3. Buttons 1, 3, and 4. Remember to ignore the first 0. And then this takes 2. I have the test input right. I don't like run out of RAM or run out of, like take an hour for this to run for the real input. So why doesn't it just work for the real input? Wait, because I'm pressing 0. I'm pressing 0 every time. Okay, so that's still 7 because of this stupid fucking C code. They could just make an extra variable, right? Is there really no better way? I don't know. Maybe this is a good way to do it, but it seems confusing to me, man. I'm gonna be on cooldown now. It's gonna make me wait like 5 minutes before I can type something. Okay, that's lower. My last answer was too high. 1 minute. It's probably been a minute. Close to it, at least. I'm... Here's the thing. What if part 2 is really easy? The only thing driving me to do this is competitiveness. But I don't care where I am on some private leaderboard. There is no global leaderboard. I never cared about that because I can never even get close to it. Like, why should I risk going insane and not sleeping for the nth night in a row? Yeah. So there's a risk that part 2 is really easy and I could just knock it out. But likely part 2 is going to be hard. I'm going to look at it for like half an hour or as long as I can stand to continue sitting here. And then I don't figure it out. I can't sleep. I'm tired all day tomorrow. I think the right thing to do, the responsible thing to do, is not even look at part 2, not even read the puzzle prompt. But if I figure it out, I'm going to feel so good. I think I'm not going to do it because it's probably hard. This is day 10. These problems aren't supposed to be easy. Part 1, this was the longest part 1 for me yet. But like some of these problems, it's like part 1 is hard and then part 2 is suddenly not, sometimes actually easier once you have part 1 done. But usually part 2 is harder than part 1. I don't care where I am on this leaderboard. It doesn't matter when I figure this out. So, yeah. I think I'm gonna call it a night. It was nice that brute force just worked for part 1. I want to look at the part 1 input. Well, I don't need to look at the puzzle text. I can just look at the input text file. Like, what could they possibly ask us to do with these things? There are 4 of these. There are 4 of these. There are 5, and there are 5. 1, 2, 3, 4, 5. There are also 5 buttons, but this one makes it clear. There are 4 of these. There are 4 of these, but there are like 6 buttons. So somehow the joltages are related to this. I think we have to, we're not toggling on and off, we're just incrementing by 1. Like, if that's what part 2 is, I think I could do it. I might regret this. Yeah, so that's exactly what I guessed. The only problem is, what if this takes like an astronomical number of presses? But it's not hard for me to go from booleans with XOR equals to integers incrementing by 1. That's just like changing an operator. The combination code was the hard part for me, and I kind of cheated, honestly. I just ported that C code. It's bigger, but for the test input at least, it's not like astronomically bigger. Let's take a crack at this. Let's take part 1, maybe clean it up. Five seconds. Okay, no more extraneous printing. Let's take part 1 and copy it to part 2. Don't need to know what my wrong answer was because I got the right answer eventually. I don't need this. Might enable this to debug something, so I'm going to leave that in there temporarily. Don't need this. Is the input joltage ever zeros? Do I have to escape these? Oh. Zero twice, which is 0, 0. Never even have a 0, 0. So I think, yeah, just like we never had an all false goal, we never have, like, I have to parse this. That's going to take me a minute. We never have a joltage goal of all zeros. So part 2. Just because it does take like 5 seconds to run, I might not want to rerun that every time. All right, now we're not going to do lits. We're going to do jolts. Just a little exit 0 debugging. Okay, and I should really just get rid of all of these for type checking. So I remember to replace it with something that's jolt based. Yeah, so that's what I want. And then we're just going to parse the ints out of that. And jolts equals JL jolts goal, and jolts goal is parse I32 delim, jolt string, and we're going to treat braces and commas as delimiters. Let. Okay, so that's now a syntran vector. It's parsed out of this. And now I have to get rid of all my lits and replace them with jolts. And jolts. I hope I'm modifying part 2. Okay, I'm modifying part 2. All right, type checking is going to help me out here, but I just know I have to do it. So state is going to be 0, not false initially. And then instead of doing this, now I should be able to use vector or array operations. State plus equals buts. Buts is not going to be Boolean, is it? I think I want them to be ones. All right, where are we? Do we have any lits left over? Nope. That went back to part 1. Buts are integers now. I think that's it. 33. 33. Hopefully this scales. And it's thinking. Maybe we need a little progress logging. This might not scale. Yeah, so we have like 230. Yeah, so that's big. We can't have like 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6, 7. You can't have like a 7-digit number in base 230. You can't brute force all those. Yeah, so part 2 is not easy, and I regret looking at this. So I'm gonna call it and go to bed. Is this Dijkstra in disguise? This might be Dijkstra in disguise. If it's not, I have no idea how you do this. Yeah, but I'm not going to do this tonight. So, well, it works for the test input. So let's say I got all of part 1 and I got half of part 2. So, I mean, that works. It's fast. It just doesn't scale to the real input. Let me encrypt my inputs. So encrypt the input and encrypt the test input. At 2025, day 10, part 1.5. I did all of part 1 and I did half of part 2. It works for the test input. So that's not nothing. I did the easy part. I changed my booleans to integers. I didn't do the part where you figure out how to make it scale. So, yeah. Push it. Well, I don't feel bad about that. I don't feel like I was close. I just have no idea how to optimize part 2. Yesterday, it was like something geometric that I could visualize. Now we have like an abstract 7-dimensional problem where we're trying to reach a point. Then we have the claw problem. There was like a claw machine problem where you're trying to reach a point with button presses. I think it was another button press day. Maybe I'll have to go back and look at the claw problem. But I feel like that, I remember that being like an earlier problem that just wasn't that hard. This feels hard. And I encrypted it already. Decrypt. But these are all ones. It's like move 1 on component 4, move 1 on component 5, move 1 on component 6. Can you just go in the closest direction? Because these are like directions in what, 7th dimensional? 1, 2, 3, 4, 5, 6, 7. Yeah, 7th dimensional space. So just start at 0. Figure out which direction is the closest direction to this, move in that direction. And it's going to take you like a little bit off course. It's not perfectly in the right direction. So the next step, you check again which direction is the closest and just move in the best direction. But then I feel like you're going to end up in a rounding error situation once you start homing in on the point where moving in the closest direction might not be the right thing to do. But at first, when you're like 230 units away, I think that's the right move. Yeah, I don't know. Maybe you could, I don't know, adapt your strategy as you get closer, but I don't want to think about that. It's a little bit tempting to try to do something, but I have to go to sleep. So yeah, here's part 1 and half of part 2. Works for the test input. All right. I'm not even gonna check how many viewers I have to even consider doing a raid. So yeah, that's gonna be it for today. I appreciate anyone who tuned in, and I will catch you next time. Bye.